Hi there, Adam here, and today I'm going to teach you about 3D printing and how beautiful it is. What is 3D printing? First of all, you must be asking. 3D printing is the process of creating a physical version of a digitally created object by way of placing layers one on top of the other. It's basically a regular printer, but just isn't as two-dimensional. Anything you can think of. 3D printing provides an inconceivable amount of possibilities. Broke a shelf? 3D print it. Want a cool figurine? 3D print it. Need some desk organization? 3D print it. Heck, you can even 3D print houses or computer cases, for God's sake, if you have the right material. Two sections of 3D printer. Now, when you're designing on 3D printer, you can fall into one of two circles. One being consumer and one being industrial. So, consumer printers, they're kind of for hobbyists, people who want to get into 3D printing. So like if you kind of want to make little trinkets or figurines, stuff that really isn't that functional, or even you print small functional parts. Consumer printer is the one for you. Mostly because most beginners don't have much of a budget, so consumer printers run for about as low as 200 euro or dollars or pounds, whatever currency you have. Which is actually quite affordable for some people, and these get some pretty good 3D printers. So industrials, these are the big guns, the ones that basically nearly all companies use to make all of their parts. Like say one of these printers right here could have made a part in your car. They've got all kinds of bells and whistles. Firstly, an enclosure, because really, the types of materials that are used in these things can melt very easily if the temperature is not regulated. Also, you got a little touch screen, because, I mean, who really has time for knobs anyway? And it's got other few bells and whistles, like also bed leveling, heated build plate, all of that jazz. Many methods of 3D printing, so these are the two most common methods you can use to 3D print something. FDM, or fused deposition modeling. This uses an extruder and hot end combo to heat up a plastic known as the thermoplastic, which is moved around in the shape of the object you wish to create. SLA, or stereolithography. This method uses lasers, yes, really lasers, to cure a special type of resin, not the kind found in trees, to produce your object layer by layer through copious dipping through this UV curable resin. Use deposition modeling. So here's a little diagram here of the hot end going across the build plate, laying down the filament. That's what the thermoplastic is called. And so this is like in the shape of like a cube, but you can make it like a figurine, a knob, a container, whatever. So, it is the most common method of 3D printing. Materials pushed in an extremely hot nozzle. Don't want to touch that. So it can be laid out in the shape of the print. Material pushed using pressure and heat, because it's got a really thin ass hole for the film to be pushed through. Stereolithography. And this is a funny little GIF showing how it's made. So you can see the laser here, which is shooting it down onto the resin in like a pattern similar to what an FDM printer would do, and so the print, and so the build plate moves more and more up towards the laser, creating more and more of the print as it goes. So it's sitting in this liquid polymer, otherwise called as resin, which cures as the laser moves around it. So rather than the build plate moving away from the nozzle like an FDM printer's build plate actually moves up. The process. Probably what you've all wanted to see. How do you actually start 3D printing? Because yeah, it's cool to know about all the methods of it, but how do you actually get started? Well, here we go. So how to get CAD models online? You can make ones yourself, but let's just cover the online stuff first. There are many sites you can use to acquire yourself a CAD model. So So these are like the three popular like kind of platforms for getting yourself a 3D model so you can start printing. So for purely 3D printable ready models, there's My Mini Factory and Thingiverse, which have like an enormous library of models that other people have made that they share with the community. And then there's GrabCAD. This is kind of CAD models that can, yes, absolutely be used for printing, but they have to be resized or redone slightly if you want to get the results you want. So CAD models, the ones you make yourself now. If you want the it's like if you're looking for a really specific thing you can't find it anywhere, then you're probably gonna have to end up making it yourself. So luckily there are tons of options. For to make your own models, here's some options as to how. So OpenS, CAD, Fusion 360, and SolidWorks are all very popular, very well-renowned CAD software. SolidWorks and Fusion 360 are normally taught in secondary schools as part of the technical graphics subject, and then Blender. This is a new contender in the ring for CAD software, since it's kind of like a gray area. Like if you can get the measurements right, you can absolutely also use Blender for 3D printing. It's got like all this software has like a great community for help and everything if you ever have any trouble. STL files. Here we go. We're getting to the good stuff now. Exported from 3D software to STL so the printer can read the file. So all these things right here are called tries. These are points strung together to make up the shape of the model you wish to bring from the digital world into the real world. And it is the most popular 3D printing file format pre-slicing. So then slicing software now. This is where we this is what we'll be using. So this is what you'll be using to turn STL file into a G code file. We'll talk about that in a minute. So you can start printing, you can start bringing your object into the real world. Huzzah! Presto! So there are multiple sizes available for purchase or for free. Yeah, some of them you do have to buy. It's a bit annoying. We got Simplified 3D, Slicer, and also Prusa Slicer and Cura. Prusa Slicer is the only one here that actually needs a specific printer for it to work. Guess which one it is. Yeah, it's the Prusa printers. So Simplified 3D, and actually now Simplified 3D is the only one here that you actually have to pay to get, but the rest of them, they're all free to use. They're all open source. They're all free. So now here comes the process of actually preparing your model for print. So what a slicing software does is it slices your 3D model into multiple layers so the printer can actually read it and print it. So this is also where this is your last chance to change settings before the print is sent off to the printer and it prints. So some settings to keep in mind: infill controls is like basically the amount is how dense your print is. Layer height, how high each layer is. Temperature, how hot the hot end and the build plate is. And then speed, how fast the nozzle moves around it. So you can either have like a Speedy Gonzales or have it like the Tortoise from Tortoise and the Hare, where it just moves at like 0.1 miles per hour. And now these are some concepts or printing terms you might want to get familiar with. It'll make things a lot easier, I swear. So bridging. So this is basically when the nozzle goes from one point to another over midair without anything below it. So it's fine for short distance, but if the distance gets greater and greater, the plastic, the filament begins to droop, and it's not really what you want to see. So watch how far the bridging goes. Now, overhangs. This is kind of like bridging, but kind of not. It's when the printer tries to print in mid-air at a 90-degree angle and you get all this messy stuff. It's basically called plastic spaghetti, which basically what happens when the printer tries to print in midair. So if you want to avoid this, you want to get something called support, which is this stuff right here. Support is basically extra material that the printer lays down to help support these overhangs so you don't get all this nasty spaghetti business, because believe me, I've seen it a few times. It looks disgusting. It looks very undesirable. Infill. So now, as mentioned in the slicer settings section, this controls how dense you want your print to be. So if you're not going to be using it much, or if it's not going to take much punishment or strain, you kind of go with like 20 to 35% infill. It's pretty good for most things that don't really get used much. And then if you say you're like kind of gonna like print a shelf or like a money box, or anything that's gonna take a lot of punishment, it's gonna be used a lot, it's gonna take a lot of strain, you want to kind of up that infill greatly to say the 50s or 60s. That's usually usually a safe point for me personally. G-code and toolpath. Come on, we're almost there. File format that the printer can read also acts as instructions for the printer. This code, otherwise known as the toolpath, tells the nozzle where to go, how fast to move, etc., etc., by using commands generated by the slicing software. So these are all commands that the printer uses to know where to go, what to do, all of that jazz. So stuff for the nozzle, movement, speed, everything that the printer would need to do is inputted right here. And it's automatically generated by this little guy, the .g code file. This is generated by your slicer software when you slice the model, then generates all of this, which the printer can then read. So finally the printer can read your model. Hooray, we're almost there. So these are 3D printers. To load your magnificent model onto your printer, you can either send it via internet or shove a USB in the printer and access your model that way. There are some different ways the printer moves about. These are some of them. So Delta, this is like kind of like a circular print bed that like, and like the hot end is held by 3 motors in a triangular pattern, which helps us move about. Like if this goes up, it goes left, upwards, right, etc., etc. Cartesian, this is more commonplace in 3D printers. This is kind of where the hot end moves around in like a square-like pattern to generate the model that goes from left to right, side to side, up and down. So 3D printing materials. So to print, you obviously need material, and with different types of printing, there are also different types of materials. Filament, FDM printers, PLA, polylactic acid, TPU, ABS, nylon. So nylon on fiber is very good for most structural things. So nylon also good for phone cases. It's obviously not the only use for it. Then carbon fiber, I've mostly it's mostly all the time used when structural integrity is involved in them. Water soluble. This is going to be a time saver for supports, because you just dip the print in water, support just melts away. Very, very good. Very, very easy for cleanup. Resin, SLA printers. So this is the resin I was talking about earlier. So yeah, this it usually comes in like 500 ml bottles, and some they come in those like gallons. And resin has fair share of uses as well. So it's called dental resin. Yes, you can 3D print frickin' dentures with this. Flexible, tough, clear, etc. So kind of similar to filament, but it's like got like much finer detail because you're dealing with liquid instead of melted plastic. Moddable components. So these are the components these are some of the components you can modify in your printer to get at least some better performance or improve your performance slightly. First, you got your nozzle. This is what allows your this is what the filament, the plastic, is pushed through to make that thin strand of melted plastic that makes up your model. Made out of various materials. Ruby, brass, or hardened steel. Hardened steel is very useful for carbon fiber or nylon, just keep that in mind. Those come in various sizes depending on what you need to use them for. So 0.4 is the standard 0.4 millimeters is the standard size for nozzles, but you can also go 0.2 millimeters or 0.6 millimeters if you so wish. Oh god. Build plate. This is what your print is laid upon when it's being printed. So it needs to be heated so the print is actually attracted to it. But you also need to be very careful with that temperature as well, just so the print just doesn't peel off. Don't have them printer defects. So this is also made of various materials. You can have glass, which is very, very good for adhering prints. Textured, again, kind of serves the same purpose as glass. It's very good for adhering purposes. And also it makes a really cool pattern on the bottom of your print if you like that kind of stuff. And then flexible. This is really, really useful if you have trouble getting your prints off of the print bed. Really useful. So then, the heart of it all, the extruder and hot end. So you can have two ways of mounting this on your printer. So most printers, specifically DIY ones, they most often come with a Bowden extruder, which basically has the extruder and the hot end separate. Both of them are connected to each other via a tubing made out of PTFE. But then another setup the more experienced users use is direct drive, which eliminates retraction, which is basically how far the filament is pulled, but before it's then reinserted into the nozzle. This is mostly happens in layer changes or when the print is moving. So unless you really, really need to unless you really need your minimal retraction, I wouldn't suggest going for this. It's great. It's great to have because you can print a lot more materials with it. But if you're only using your printer for like a small variety of uses, I wouldn't go for a direct drive. I just go with Bowden. The only upgrade I'd suggest for this is getting something called Capricorn tubing. It'll help out a lot. So if you actually want to go further, expanding your knowledge, if you actually want to pursue 3D printing as a hobby or heck even a career, you can see these are actually two channels I highly recommend. They're very good. They're the people who run them are actually quite good at explaining 3D printing. There's Teaching Tech, who does a whole heap of tech related stuff. Well, obviously, hence the name. Then Maker's Muse, very good at 3D printing, very, very, very good at just like tips and tricks and all of that stuff. Hope you enjoyed this. Happy printing!